Okay, so hopefully everyone should be able to go on the stream. Can you see GeoGebra Joe on the live stream? No, on oh, I'm echoing. Mute myself. Okay, so I have a diagram now, so that's good. Okay, so just right angles. So, okay, what's P and Q? This is useless. Let me start removing some of the not so useful stuff. Actually, yeah. I mean, I really think we do want to just show that AB equals BY. That seems like the most natural thing to show, but do we know anything about like triad circles that go through the in center? I guess that like the centers are on these lines. I don't think that particularly helps though. Maybe it does. This isn't a parallelogram, is it? No, it's not even close. Ah, okay. There's probably been like a 10-second delay or something. Oh, nice. It doesn't help. I guess we know this angle, like YAC is the same as YIC. Then just because they lie on like the big circumcircle. Okay, I'll try and check. Joe, can you just speak? Okay, yeah, you're not audible. You're not audible. Let me remove and add it again. Okay. I think it's because it went out of frame. Joe, can you talk again?
Testing.
Yeah, okay, that should be fine. Just move it out of frame.
Cool. Yeah,
It's like 5 a.m. here. I should probably sleep.
Okay. Bye
So I'm
then.
gonna go. So yeah.
Mm-hmm. It suffices to show that the angle ABY is the same as AYB, right?
Mm-hmm.
And I'm just trying angle chase on paper. I don't know if it'll actually work. It's the same as showing angle A is equal to AYV plus YAC, that little one. But then I don't think we can really say anything interesting about this angle, the AYB, so that'll work.
Yeah, I was being kind of so we've got angle PQ. We've got angle AXY is equal to 90 minus C over 2. Still all assuming my claim.
Wait, what claim?
That what you were trying to prove, basically. The
Oh, right, yeah.
the right angle stuff.
I mean, we can write
Okay,
angle.
so now I need to prove that PQA is equal to that.
PQA. What do you want PQA to be?
I'm trying to prove it's 90 degrees minus C over 2.
90 degrees minus C over 2. Yeah. I think we're vaguely doing the same thing, just on different parts of the triangle.
Yeah.
Angle BAX.
Oh, bruh. Okay. Yeah, because we're claiming it's the orthocenter, that means that PQA is 180 minus PIA.
Yeah, from the claim, yeah.
Yeah. And then yeah, PIA. That's just 180 minus A over 2 minus B over 2, which is going to be 90 minus C over 2. Yeah, so we're done. with that part of the question.
But we still have to show the first claim.
Yeah.
Yeah, that's what I'm trying to do. Yeah, I think we
Okay.
can do that.
I'll try and do the right-angled thing.
Yeah. Okay, I have a claim which pretty much would finish.
Mm-hmm.
The circle centered at I through A hits a BC at X and Y as well.
Hmm.
And that would finish by just angle chasing
Okay.
afterwards once you have that circle. So I think that's probably a better
Okay.
claim to show than directly angle chasing because we're sort of done after that. So how do we define... So that's just circumcircle stuff, so we can kind of get rid of a bunch of points then, I think.
Wait. Nah. The right angle thing is actually really easy to prove the isosceles triangles. I'm blind, right? So it's literally just B X A
What's E? Oh yeah, the
is equal
point,
to
yeah.
B I A.
Equals
And yeah, I'll just draw an AI shit line. Okay.
You're on the whiteboard.
BIA. That's not 90 plus C over. Yeah, 90 plus C over 2.
Let me just pull up the... I think the whiteboard on our stream is dead. Me.
Okay, so then yeah, so AXC is
Let me zoom out a sec.
90 minus C over 2.
So AXC is 90 minus C over 2.
Yeah. Okay. Now we need to look at CAX, which is equal to CAI plus IAX, which is equal, and IAX is IBX. So then we're done, yeah?
Yeah. Oh, okay.
Okay. That took way too long.
Yeah. I think there's another way to do it as well. By showing that, but it's the same. It's just an angle chase. And I think you do the same thing where you get this equal to whatever.
Okay. I'll just write it down. Okay, CAX.
I mean, we can write it up later anyway. We can just go to the next question.
I mean, will we remember?
I mean, there wasn't that much to it. It's just angle chase and follow the things. I think it's fine.
I'll just quickly write it down anyway. Just
you can write down. I'll open the next one.
Okay.
Okay, I'll move over to the side for question 2. So, question 2. We have an integer n, and the numbers written in order on a blackboard. We have the following moves. Let's do like 1, 2, 3, all the way up to n. Take 3 adjacent numbers whose sum is a multiple of 3.
Yeah. Okay. I've written it out.
Okay, do you want to look at the second problem then? Either just go to the right hand side of the
Yeah.
board.
Sure. Hang on. Where's you got the actual question there?
Oh, I can put it onto the board as well. Give me a sec. Image. Do you see it?
Yeah.
It's also on stream separately in the bottom corner.
Okay.
Anyway.
Okay. So.
So let's move it up to here. And then. Okay.
Okay, so we're allowed to do a cyclic permutation of 3 if it's a multiple of 3. And if it's a difference of 3, then swap them. Okay. I bet this is going to be some kind of invariant.
Yeah, almost certainly. So wait, what do we want to get at the end? We want to get n1, 2, 3.
So we basically
so we
want to cyclically permutate all of them. Okay, so with n equals 2, n equals 2.
Wait, where are you writing? Oh, right further down. Right, like below
I'm
the
at
1,
the
2,
top.
3. Yeah.
Oh, sure. Okay.
Well, n equals 2 is just the case 1, 2. And then nothing happens, so then we're done. So it doesn't work for n equals 2.
It doesn't work?
Yeah, because we only have 2 moves.
Sure. N equals 3.
N equals 3, we're done. Yeah, because we do 1, 2, 3 goes
fact,
to... Yeah, so...
Any multiple of 3, we're done.
Any multiple of 3, we're done.
Yeah, I think.
Oh, yeah, so we basically... We look... Is everything... Oh, it's the sum... Sum and difference, multiple 3. Okay, so we need to just look mod 3, right? So we've got, like... We really have... like 1, 2, 3, 1, 2, 3, and so on, up to like a 1 or something. So then it's just what happens when we...
Then you basically just push a 1 forward. Okay, what about if n equals
wait, what do you mean
3k?
just... What do you mean just like push a 1 forward?
Are we doing a multiple of 3 case? So like for 1, 2, 3, 4, 5, 6. First we do 1, 2, 3. Then 1, 4, 5.
Wait, but 1, 4, 5 isn't a multiple of 3. It's 10.
Oh shit. Okay.
So all we could do here is we get like 2, 3, 1, and then we'd the only move we have left is 4, 5, 6, which gives us
sure.
6. Oh no, what am I doing? 5, 4, 5, 6, 4.
Yeah, 4, 5, 6.
But then we have a middle move.
Oh yeah, 1, 5, 6 now works. So 2, 3, 5, 6, 1, 4.
Then we don't have another move, I don't think, do we? 5, 6, 7, 8, 9.
Okay.
Okay, so that first move doesn't work. What about the middle?
Okay.
We have a different starting middle move. We can do 3, 4, 5, right? Because 3 and 4 is 7 plus 5 is 12. That gives us 1, 2, 4, 5, 3, 6. Yeah. Then... Okay, I don't think this is necessarily going to help.
That's...
Okay, so...
I think it will help.
Okay, let's try n equals 4 first. Let's just make sure that's not possible. Because we're still getting a bit ahead. rather than trying to do the general. So, because we know 2 is bad, 3 is good. So we get 1, 2, 3, 4. Our only move is 1, 2, 3. So we get a 2, 3, 1, 4. And then we have no moves, do we? Oh well, we can do this one again. Oh, we can shift things multiple times, right? So given.
Yeah.
But then we'd have to end up with the right thing at the end, but we can see anyway. So we can do that again, I guess. That's our only move. So we get what, 3, 1, 2, 4. Still no good. Actually, I'm just thinking this isn't going to change, right? Because this is always 1 mod 4. And this sum is always 3. And then we're always never going to have a different move. So we can just only cyclically shift this start bit, and then it'll never work. So we're done, right? So 4 won't work.
Hang on.
Just by exhaustion.
For
Oh wait, I didn't try the difference of 2.
1, 2, 3, 4.
Sorry, we've only tried the first move, right? We can, yeah. Okay.
Oh.
Yeah. So we've only been trying to do the first move, so of course this didn't work. So we need a difference of. Okay, so we can only shift until. We shift until we get a difference of 3 between 2 of them. So that would need to be. We can get a 1 and a 4. Oh, okay. So we actually have a different move we can do here then. We can do. Why is that highlighting? I want to delete. We can then do move 2 on this at the end. And that gives us 2, 3, 4, 1. And then we're done. That's what we needed, right? Oh no. We wanted 4. We want like 4, 1, 2, 3. This is a multiple of 3, so we can just shift multiple times, and we're done. Just do it twice.
Sure.
Yeah. So that works.
Okay, and then can you literally just do the same for 1 mod 3? I figured out how to do the divisible by 3 case.
Oh, you did? How do you do the divisible by 3?
So for 1, 2, 3, 4, 5, 6, I'll just write it out again. You can firstly do it on the last numbers twice, right? So you get 1, 2, 3, 6, 4, 5.
Mm-hmm.
And then swap 3 and 6. So 1, 2, 6, 3, 4, 5.
Yeah.
And then 6, 1, 2, 3, 4, 5.
Oh,
and I'm pretty sure this works for like anything.
So I guess we have to do the general argument.
You can inductively do the same, yeah.
Okay.
So it works for multiples of 3.
This probably I would guess this works for multiple for like 1 mod 3 as well, by doing the same thing.
Yeah, definitely.
By the same trick.
So yeah.
The induction is pretty easy as well because you just do the blocks of whatever mod 3.
Yeah. Okay, so we're done with those 2 cases, right?
Pretty sure.
And then it's probably going to be we couldn't do n equals 2.
Which is 2 mod
So I'm guessing we can't do n is 2 mod 3.
Okay. I'm just going to try to do 5.
We look for.
Just make sure, because it could just be small n, but.
Oh yeah, true.
I doubt it though, but it's worth checking. So our first moves are obviously we have to do a multiple of 3, so we can do 1, 2, 3, or we can do 3, 4, or 3, 4, 5. We can do either, right? So that gives us 2 branches. So if we do 1, 2, 3, we get 2, 3, 1, 4, 5. Or if we did the last ones, we get 1, 2, 5, 3, 4.
this is not going to work.
Yeah, this is gonna give us. Yeah,
So
I'm feeling this one.
I'm trying to think of invariants we
Yeah.
can use, and my first guess is something like I don't know. This often tends to. So the sum obviously doesn't do anything.
Yeah.
But what if we look at 1 times the first one plus 2 times the second one
Yeah, I thought that
plus
as
3
well. I
times
don't know
the
if it
third
actually.
one,
I,
and so on. Hang
or
on.
just
Yeah,
do. We could
I
just do
think-
like 1 times the first one, 2 times the second one, 3 times the third one, and then back to 1
Yeah.
times the fourth one. Yeah. Does that?
I mean,
let's
yeah,
see.
yeah. I think it's the same mod 3, but then it's gonna be different for
Oh,
like
why did I rip it out? So wait, what?
-2.
So what are we saying? 1, 2, 3, 4, 5. This would go to. What's gonna be 1 by 1. So 1 plus 4 plus 9 plus 4 plus
Yeah.
10. So what, like 5, 9.
Hang on. Is it not just easier to So what's a formula for the sum of squares? It's something like n times n 2n. Shit. What is the formula?
Something divided by 6 with a 2n times something in there.
No, never mind. This is 8.
Okay, wait.
Yeah,
just,
actually,
well,
it's easy. It's easy because I'm trying to do the difference between the two configurations, right? The start and the end.
Yeah.
So that's actually going to be most of these. You're just taking away 1, right?
Well, we're gonna look at the
then-
invariant mod 3, right? So we can just add 1 to everything, or subtract whatever.
Yeah. So basically, you want to look at 1 squared plus 2 squared plus blah 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 plus
Yeah.
n squared, and then subtract. It's going to be 1 times n plus 2 times 1, and so on. Oops.
Yeah. Plus 3 times
Um,
2 plus
n minus 1
n minus 1 by
times.
n. N times n minus 1 at the end.
Oh
Yeah.
shit! Yeah. Okay. Yeah, and then the difference of these is just 1 minus n plus that's just
2 times
the
2 times 2 minus
nth
1.
triangular number minus 1.
That will be by
So-
summing everything up. Wait.
Yeah, this works. And then if n is 2 mod 3, you just plug it in and get that it's not a multiple of 3. So 1 minus 2 mod 3, that's 2 mod 3. This is 0. So this
It's 1
is
or mod 3.
not 0 mod 3.
Okay, we just need to like carefully check that these rules do preserve
Yeah,
our rule.
so we need to check that doing the rules it doesn't change this invariant mod 3 because we literally just guessed this invariant.
Yeah. Okay, so we've got like 1, 2, 3 on a block of 3, and that goes to. Well, it has to be in any position, right? So I think we could probably just brute force and just check.
Hang on. Doesn't have to be. Could it be A, B, C, and then B, C, A? Where A plus B plus C is a multiple of 3.
Yeah. So a plus b plus c, 3 divides. So then we've got our original invariant is a plus 2b plus 3c, and it goes to
Yeah.
b plus 2c plus 3a. We want the difference. So b
Yeah.
plus 2c.
So which is
Oh, is it 2a b c?
a plus b minus 2c, which is a plus b plus c. Yep, it's all good. Okay.
Wait, a plus b plus c is 3a plus 2b goes to b plus 2c. Okay, and then the second one is the difference of 2. Oh, and then we can swap if the difference of 3 between the two. That's the same mod 2, so that obviously preserves. Oh no, that doesn't obviously preserve things. I don't think the second one necessarily works. If the difference is 3 between 2.
Really?
Yeah, swap 2 and 3.
A b.
No, just do the actual example. Like 2, 3 could go to like
3.
Goes to 4 and 4 plus 9. Or it goes to 2 by 3, 6 plus. Oh, well, yeah. Yeah, it's 13. It goes to 11. Yeah, I don't think our second move works.
That's really annoying.
I think it's because we've distinguished like blocks of 3 and then non-distinguished blocks of 2. So obviously blocks of 2 are going to be fucked up. Okay. I mean, we still do have an invariant for the number for the
Hang on,
first moves.
no, Adam, the difference is a multiple of 3, right? So a minus b.
Oh wait.
So a is equal to b mod 3.
Oh, okay. Well, but wait, no, but that's still like you still have like, let's say like 2a plus 3b. Actually, I guess this is the same term.
You
Yeah,
might
no,
as well
right.
just write
You're right,
2,
you may as
2a
well.
plus 3a, and then swapping it literally does nothing, so we're fine.
Yeah, okay, that's fine. So our invariant works and then we're done. Okay, easy.
Yeah.
Okay.
Okay.
Right.
So, I guess
I don't think we
question
need
3
to wrap
now.
it up. I think that's like straightforward enough. Yeah, okay, go below and I'll paste in the question. And then I'll change it on this.
Alright.
Okay, there's question 3, and then let me get something else. Okay. So question 3.
This looks like some dread.
Right.
Okay.
So we have an end list if every AK is in the range. Okay, so it's just like an element of. So this is 3. One sec. Start my washing machine going back on. So you have A is in, I guess like Zn to the end. Yeah.
Wait, am I being dumb, or can't you literally just set all of A1 to AN to be the same thing, and then
Wait. Sorry, I haven't read the
just,
question. Wait, so we have the minimum possible value of. Okay. Across all n lists, we say it's ideal. Okay, yeah. What's your suggestion?
Oh, for fuck's sake, it says non-zero. Okay. What I was going to say was, if we just set them all to be the same thing, then all VMK
Yeah,
is
they're all
just
equal, yeah, and then it's 0.
0. Yeah.
But then it's the number of ideal lists, not like
It seems kind of weird
that
that
just constructs them.
you can make them all minimal, which probably means that you can just do them one at a time. Like do it for K is 2. Nah, 1. A1 plus A2 divided by 2 minus
A1.
A1. Okay, so the smallest you can get that is when the difference is 1, right? So
Yeah.
say that K and K plus 1. Okay, and that's got to be the minimum.
But like
and
surely
then,
the minimum in all cases is it not just gonna be like it's non-zero value? I don't get it. Is it not just like the list 0, 0, 0 all the way up to like 1 at the position K? Or K plus 1 and then zeros everywhere else?
wait, do you understand the question?
Wait, what do you mean?
This wouldn't work for earlier K. Oh, hang on. Yeah.
No, it says
It's
one
the
in
minimum.
H.
So
Yeah. Also, AK
wait.
is just in the
So
range of 1 to n. Oh, well, it has to be 1. Sorry, not
A1
it can't be
plus
0. So it's gonna. I mean, well,
A2.
increment this by 2.
Yeah. I know what you mean. Yeah.
Like 1, 1, 1, 1, and then a 2. And then the difference is
Yeah.
obviously going to be
So
2 over K plus. Oh no! Wait. 2. The denominators make a little bit of a difference. I don't know if that actually.
if we just substitute K and K plus 1 into this, and it could be in either order, which means that this is equal to 2K plus 1 plus A3 divided by 3 minus K minus a half.
Where's 2K plus 1 coming from?
That's A1 plus A2.
Why? Yeah, but why are we dividing? Wait. Okay, right. Yeah.
Oh, because I let A1 and A2 be K and K plus 1 in either order.
Okay.
Yeah, okay. And then this is equal to 2K over 3 minus K. That's minus K over 3. Plus 1 over 3 minus 1 over 2. So that's minus 1 over 6. Plus A3 over 3. So we want that to be minimum possible without it being 0, which means that I think we can just get rid of the 3's here and put factor 3 here.
Factor 6, but yeah. Like factor 6 and put some multiples in.
Oh, I was just gonna make.
Oh, it doesn't matter. Yeah.
Yeah. So that means that
Well, A3 is gonna be like
K or K plus
K.
1, and yeah.
Yeah. I still don't really fully get what way you're trying to make this argument work. Like why are we saying K and K plus
what
1?
I'm thinking is because I literally just defined A1 and A2 to be K and K plus 1 because we proved that their difference is 1.
Right. Okay.
Yeah.
That's fine.
Okay. Then actually, we didn't need to do that case I did just then. You can actually just do induction. Yeah.
I mean, I think it's just from
So
like I used to k plus one.
they're all gonna be
I think it's probably going to be k plus
k
one.
or k plus 1, right? I think.
Yeah, I mean, it's just this example, right? It's the same as this example, just like add on some multiple. But I'm not sure if that differs by k, but like if you add like k to each term, it all gets divided by k or k plus one or whatever. So it's the same. So it's just like, is it not just this example plus like, I don't know, maybe not like, I don't know, like an m for any m, and that gives you the minimal one.
Hmm. Sorry, I kind of tuned out for a minute. What did he say?
Okay, so is it not that like all of the minimal? I would say that the minimal ones look like this, right? Where you have a bunch of ones and then increment by one at the end, right? Because there's no distinctness thing,
Yeah.
and then, but then we can just to get all the other ones, we probably just add on some constant to all of the terms, or maybe we can just add a constant to some of the terms, which is what could make it more complicated. But
wait, so
this should fix the sum of the minimal
we're
one.
trying to. Oh, we're trying to find the number of the
Yes.
ideal n lists.
Yes.
So surely.
So the way I was
can-
thinking to do is you basically find what nk has to be by picking an example kind of like this, and then given an mk, we can then try and figure out how many lists fit into that particularly.
I feel like we can literally just work out the lists explicitly because with the same reasoning here. Okay, let me just. Yeah, so yeah, this is exactly what you were saying, actually.
Like
So,
I think what I'm basically claiming is that like mk is equal to, I guess in this example it's like k over k plus one.
yeah.
Does that seem correct?
So this you're saying this is
Oh
the
no, not k plus one. I think
minimum.
one over k plus one. Sorry.
Yeah. And that's always achieved.
And that's always achieved with this example.
When, or it could be any order, right?
Yes, the order doesn't matter. Oh no, the
Yeah,
order does.
so-
No. Sorry, the order of these terms don't matter. The order of the last one obviously has to come last.
Yeah.
So then we fix the sum here, right? Okay, so that's all. All that said, we can also add on an amount to any term, right? And then it all just sort of factors out through the end, I think.
Wait. Also, we could have like 2, 2, 2, 2, and then 1.
2, 2, 2, 2. Yes.
Yeah, we need to prove this rigorously, right?
Well, the minimality should be obvious, right? It has to be. I mean, this is obvious that it's minimal, right? Just think about the format. We've got a bunch of integers divided by k plus 1. Oh, well, I guess it could be smaller.
Yeah.
Could it be smaller?
Okay, so I think we can just say, suppose, okay, let's call it A1 up to, oh, we need another, okay, let's call it M. So suppose A1 up to AM. So this is our minimal configuration, and it's
Where are you?
oh,
Yeah.
I'm down at the
Yeah,
bottom.
I see.
So and then the last one, we can let it be A plus or minus 1, right?
That's what we're claiming, yeah.
Yeah. Okay. So and now yeah. So now we just find A m plus 1, right? So A1 up to AM.
Wait, oh, right. Oh, by induction. Right, this is the way you're doing it.
Yeah. So that's MK plus or minus 1 plus AM plus 1.
Okay,
Divided by,
I think this actually might be a kind of bad way to do it. I think I might have a slightly better way.
really?
Because I don't think this necessarily works like the induction thing. I don't think that's actually quite correct. Because the thing is, because we can arrange these in any way so that they just have the same sum, we could like add 2 to this one and then take away 2 from the middle one and we'll still get an optimal list. And we don't want to have to deal with that in induction, right? It doesn't necessarily have to be optimal for the previous list. We fix a k, right? Oh, if it's optimal for each k. Sorry, yeah, no, you're right. Yeah, wait. Oh, say an ideal if it's ideal. Oh, we say it's ideal if it works for all k. Okay. So do we? So I think we first of all need to fix. Oh no. Okay, no. My point still stands. MK is independent of this ideal property. MK is just about any n list. So we need to prove what MK is first, which is what we think is 1 over k plus 1. And I think I can prove that pretty easily. So I'm over sort of near the top again. Um, so if you just sum up, if you just like clear denominators, you get that the whole sum is equal to negative the sum of a1 all the way up to ak plus this sum or plus k times ak plus 1. And that's all divided by k times k plus 1, yeah? So then, because these are all but from 1 up to n, okay, so we'll take the two cases. I guess one case is like when this is all positive and when it's negative because we have absolute values. So let's take the positive case just to make this easier. The positive case, to make this as big as possible, we have to make this as small as possible, which is obviously when it's equal to k. So we get negative k plus k times ak plus 1 over k times k plus 1. And then this is then made biggest when ak plus 1 is as big as possible, which I guess comes from n. Oh wait, no, I'm being stupid. Minimal possible. Okay, no, we want to minimize this, not maximize it. So that doesn't actually work. So then we actually want to make this as big as possible, subject to this being positive. So I guess then we want to have a1 up to ak less than or equal to, I guess, k. Well, it has to be less than, because it has to be non-zero, so it has to be less than k times ak plus 1. Oh, you just fix the sum. You just fix the sum rather than fixing the sequence. Right. Do you get me? Yeah, yeah, so that's fine. Okay, we're doing the same thing then. Well, k is fixed. K is for the mk. Mm-hmm. This is stupid. Yeah. Okay. Okay, just to be perfectly clear, are we currently trying to prove the my bound on mk, like the 1 over k plus 1, or are we trying to prove that how it occurs? Okay, yeah, yeah. Mm-hmm. Yeah. Mk plus or minus 1 over m minus m plus 1. Mm-hmm. So mk plus or minus 1. Yeah. I guess clear denominators and then do integer stuff. So yeah. Wait, actually, we need to actually go through that, right? So, okay, ignore all these. So we get m. Oop. I'm just going to type, it'll be quicker. Let's make the font bigger. mk plus minus 1. Oh no, never mind, it's not going to be quicker. There's too much going on. Okay, so we get m times mk plus or minus 1. And because we're minimizing, we can just multiply by 3, so we can just completely ignore the denominators. And then plus m times am plus 1 minus m plus 1, all multiplied by mk plus or minus 1. That's proportional to. And we want to minimize this. So obviously this cancels with this. Yeah. So am plus 1 minus I guess that's mk plus or minus 1. And we're minimizing this. We can probably can we divide through by m? That's allowed. So let's divide through by m. And we'll leave it this to be a non-integer, which I think will be helpful. So we get a. Oh yeah, no, this will work. Oh, this says that it's equal to k. Right? Do you see why? Because we want it to be less than an integer. Yeah. So yeah. Okay. And then a3 is equal to m. That's up to an. Yeah. A2. Yeah. Okay, so we can pick m. The only one we have to care about is when we we've m small, m big, and then m in the middle, right? Because there might not be a plus 1 or a minus 1. So if m equals 1, then we just have one choice for the plus 1. Yeah. So we have 4 times the middle n minus n minus, and then plus 2. No, but we also have the edge ones. So for each middle one, right, we have 4 possibilities, right? Because we have 2 choices here for +1, -1, we have 2 choices here, right? And there's n-2 middle ones, right? And then for the end one, we only have 1 possibility here. And that means we also only have 1 possibility here. Oh no, we still have 2 possibilities, yeah. For the end one and the start one. So then plus 2 times 2. Right? Yeah, 4 times n-1. And we claim that works. Yeah. Okay. I think there's a chance we fake solve this. Like if I had to guess, but I think we should move on. I think we should move on regardless, and we'll find it when we write it up anyway. We're still have loads of time. When did we start? Like at 5? Yeah, there's 2 of us. So anyway, right? Okay, I'll swap the photo for 4, and then I will. Okay, all more geometry. It's like Compi Geo. It's like NT Geo. New. Yeah. I'm gonna go to the top, and then I'll put it in there. Give me a sec. I'll make it a bit smaller. Do you see? Okay. What's it problem 4? So this is the last problem, yeah. Okay. So we've a side that we have a triangle with nothing. Ah, Jesus. No. It's like a NT problem, so it's just gonna be properties of. Wait, A is 3B. Oh, right. Okay. Well, give an angle. Okay. Okay, let me just draw. Let me just get a GeoGebra up. What's like. um, and I'll just make it vaguely correct. Because then I can twiddle with things. So what do we want? We want angle B is angle A is 3 times angle B. Not off the top of my head. I know of the theorem. I couldn't write it down though. I don't remember the formula. Okay, easy. Let me put this in. Okay, there's a triangle. And this is A, B, C. So what do we have? We have the highest common factor. The highest common factor. Oh, that's GCD, yeah. So GCD, A, B, C. So they're all coprime. Okay. What length do we be, sorry? No, just use there's a highlight thing. Just highlight it. Actually, I don't know if there is. Yeah. Oh, right, yeah. 180 minus 2b. Yes. Mm-hmm. Wait, did you relabel B as something? Yeah. Oh, sorry. Right. This is 2B and that's 2B. Yes. Yes. That's 3B. Yes. Okay. And that's from. I don't know this formula. Okay. Mm-hmm. So A squared B minus B squared A plus A cubed O cubed. That's good. A cubed minus 2A squared B. Mine. Okay, anyway, I'll just keep going. So yeah, so A cubed minus, that's 2AB times A, 2A squared B, and then plus B squared A, and that's equal to B squared A. Oh, that's good, we can cancel that as well. Minus B cubed plus C cubed B, C squared B. Okay, so we can cancel this, then A squared B minus 2, so we just get a minus, not a 2. Minus B squared A. Do we have a B squared A term? Minus B squared A plus A cubed minus A squared B. I will just take away this from the other side. Minus C squared B. I guess plus B cubed equals 0. It's probably the way we want to write this. Mm-hmm. It's B times everything. Okay, we've got this is a problem already though, right? Doesn't every term have a b in it? Yeah, it does. Every term has a b in it. No, no, but then there's no common factor, so then a would have to be one. Yeah, they're all the GCD of A, B, and C is one. But then A divides B, or then B divides A. Well, yeah, B divides A cubed, but they have no common factors, so they're just A has to be one. Or actually, no, that's not necessarily true. Um, B has to be Yeah, B has to be one. B has to be one. Oh, sorry. Mm-hmm. No, no, no. That's what I've written down. But then, okay, okay. But then doesn't that just mean that B equals one, and then we're done because B is a cube? I don't think this is right. Then P divides A cubed. Well, then P divides A cubed, so P divides A. Mm-hmm. P divides B means P cubed is divisible by B. Okay, okay, right. Okay, just stop for a second, right? What this implies that A cubed that B divides A cubed, right? By like definition. Yeah, right. Okay, but okay, okay. What's wrong with this, right? But then let P divide B, a prime. Then P divides A cubed, right? So then I don't know Euclid or whatever. P divides A, right? But the highest common factor between oh, it's between all three. It's not pairwise. Never mind. Okay, right. Notation. Never mind. Never mind. Never mind. Never mind. That's fine. Yeah. No. Keep going. Keep going. Mm-hmm. Yes. Yeah. Yes, because it can't divide the. Um. Wait. Divides the right side. Divides a. Has to divide b squared plus c squared. Not. I don't know if we know that necessarily. Oh. Oh, it says we're live. Oh, it's stopped on like. You're not showing the whiteboard. Oh, it's frozen. Let me fix. I can fix. I can fix. Yeah, 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 yeah. Okay. Let me kill this. Uh, okay. Okay, I should have fixed the stream there. Right. Okay, so to recap, we've got this equation. Oh, okay, so and also p cubed, or sorry, if p divides b, p divides a, and then if something divides a, then it divides b, and that can't divide the third term, so it has to divide the cube of. It's a divide. Its cube divides into b. Yeah, yeah. B divides b times. Yeah. Okay, so the exact argument is that these two are co-prime because whatever divides b divides a, and then you're done. I think you're just done because then b has to be a cube, like, because they're co-prime. Yeah. Okay. So yeah, that's easy. Okay, that's fine. To be fair, you have to know this thing, which I didn't know. The steward thing. Okay. Yeah. Right. Do we want? I guess right up. Yeah, okay. Do you want to do 1 and... Yeah, it is. It is. I'll make an overleaf, yeah. Yeah, we'll use overleaf. I just need to log in and make sure I'm not leaking my personal details. I don't think I've actually made a template, but that's fine. We can just, I'll make it as we go. Do you have an email for overleaf? Do you want to DM it to me? Oh wait, turn on link sharing. Oh no, it's okay. I'll just send you the, don't worry about it. I'll just send you the link. Let me just add a window to OBS. Okay, I'll just paste in the questions. Question 1. Give me a second. So this is one of them. Then, yeah, I know. I'm doing it in reverse order. You can do what I'll type up. What you could do. You can maybe do. That's question 4. That's fine. Let's get the last one. Yeah. Yeah. Let me just upload a LaTeX template. I'm just doing LaTeX format stuff first, and then we can. Just give me a second. I'll fix it. Just start typing. It's fine. Okay. Yeah. Just use whatever formatting. No, it's just begin. It's just begin claim, end claim. You can just write it. Don't need to do any formatting. It's just fine. Oh, I made a mistake. What's complaining about? Oh, it's because you're in the middle. There we go. I just realized in our invariant we're multiplying by 3 in some of them, which just kills them. So we're really just taking like 1 plus first terms, but it doesn't really matter. Yeah, no, it just occurred to me. It's like our invariant just ignores some of the numbers. But anyway. Maybe do. Yeah. Okay. Yeah. Okay. No, I'm still typing it up. I'm just being slow. Yeah. For the invariant bit, I'm getting a different thing as the difference in our variance than we wrote down on the board. I don't know if it matters though. Yeah, possibly. I'm just gonna think about it carefully. I'll just calculate it out with the square sum of squares formula and everything. Yeah, no, don't work that so far. let's see. Um, did we show that that M is actually ideal, MK? Or that it's a minimal or whatever? Mm-hmm. I'm nearly done. Question 2. It's just taking a minute to write up because I have to do the details, which I didn't actually write down earlier. It's not exactly the clearest write up ever, but it's all there. Oh, actually, this is actually easier than I thought it would be. You can actually simplify this proof slightly. Um, You can actually do it without invariance as well, the same argument, by just literally brute forcing the n equals 5 case, like the way I was doing with like building a tree. But anyway, that's sort of, yeah, don't necessarily need it. Yeah. Yeah, I'll fix the formatting too. 2, 4, 3. I don't know if my proof is completely clear, but at least it's somewhat concise with the second bit. Okay, that's all done. Sorry, my dog's okay. I think we just need to put in also. Yeah. So that gives us, I don't think that gives us necessarily that there's a. I think we have to say something stronger than p divides a3. We have to say that the powers of p occur in multiples of 3. You can just prove it all together, I think. Yeah, just say so like if p to the something not multiple of 3. Actually, I don't know if you can. I don't know actually. Yeah, no, keep going. Yeah, I'll just write this. Then bn must be, but then factor, and so p cubed divides p. Um, this is what we want to do. Then we have to show that m is 0 or something. What way did you do it on the whiteboard? I'm not sure. I'm actually done. We don't need to do this. Wait, so this is I must. Okay, so then let be the collection of primes which divide B. Then okay, we've already got that. Yeah, we just have the p cubed divides, but it doesn't say that could be p, like p to the power 4 could divide, right? Yeah. Yeah. Oh yeah, no, I know what you mean. Yeah. Must be coprime. So if v nu p a cubed equals nu p b. Yeah. Or not a cube, should be a cube. Yeah. I think that's done. I think that's fine. Yeah, let's read question 3. Let's read. Call this an ideal k-list if 8L. Okay. This seems fine. Yeah. Okay. I think we're done now. Easy. Okay. Thank you all for watching. I hope you enjoyed our live solve. And we will post the PDF of this